In today's video, here is a nice problem that was suggested by viewer. Here is the following information. Our goal, we are going to find all primes p which satisfy these following two equations. So for all x and y as non-negative integers satisfied these both equations, we have p squared plus 2p plus 3 equals 2 times y squared. The second equation, we have 3p plus 3 equals twice x squared. So the tricky thing in this problem, when you try to solve this equation by replacing the first equation into the second equation, is not going to take us to somewhere where we can solve this equation easily. So we need to a special equation. I'm going to remind you that equation, what is the name of this equation. So before we move on to the solution, I would be recommend to give the hands to us from prior to solution. Go out, pause this video when you want to come back to see the solution. By the way, don't forget to hit the subscribe button, support our channel, like, comment, and subscribe. Now let's jump into the solution. So before we get started, I would like to remind you about a special equation. It's called Peel's equation. What's the Peel's equation definition? So Peel's equation is written on this form. We have x squared minus dy squared equals number 1. This is a special case for the equation. This is a special case for the Peel's equation. Okay. The general formula for the Peel's equation, this one, x squared minus d is multiplied by y squared equals n. Okay, what is the n? Is an integer, like this. This is the general definition of this equation. So if I'm trying to find the solution for this equation, so it's simply by recursion. We are not going through the proof, just I'm going to give you the general solution. So this one is going to be written on the form of x minus square root of d y factor x plus square root of d. Square root of d is multiplied by y, like this, equals number 1. So in order to find the solution for this equation, first of all, we are going to find a small solution which can verify this equation. Let's call this one x0. So it equals, let's call the small solution x0 and y0, okay, which can verify this equation. So the general solution for this equation, we are going to take this solution like this. Let's put it as alpha equals x0 plus square root of d y0, all is raised to the n as an exponent, where n is an integer. This is the solution. You are going to find the smallest solution for this equation which can verify this equation. Then you try to write your solution on this form, on the form of the recursion. Okay. So as you change in the value of n here, you get a new solution. We will have infinity many solutions for this equation. Okay. You get the first solution, second solution, and so on and so forth. This is the solution for this equation, is going to be written in this form. But this one is going to be happens for the equation which has number 1 as a value here. But what about the second equation, n? So to find the solution for this equation, for the second equation, we are going to check first. You are going to check another solution for the second equation, which is going to be like x prime, for example, and y prime. Okay. But the second equation, you cannot use the recursion here, because this one is valid only when you have number 1 here. Okay. So for this one, it is going to find a smallest solution which can verify. It's more simple to find it. Okay. Then take this solution, which is going to be written on the form of x prime 0 square root of d and y prime 0, like this. Okay. The solution we are going to find, like alpha prime as a solution for this one, equals this. Let's call this one is a beta. Alpha, which is the first one, is multiplied by beta. Then we take this solution which we have before as a recursion, but this one is going to be when you have n equals 1. Remember here we are taking n equals 1 as the first obvious solution for this one. Okay, we are going to keep the first solution as we have here. So alpha is multiplied by beta is going to be x0 plus square root of d y0, it will be multiplied by the second solution which we have here, x prime 0 plus square root of d prime 0. So remember this solution for this equation, but the first one for the first equation. To find a general solution for this one, you are going to multiply this one by this one. Okay, so you get here, you will find another solution is going to be written on the form of x1 plus square root of d y1. So which means the solution for this equation is this one. Okay, it's more, I think it's more clear here. Now let's get rid of this one and move on to the problem. Now we are ready to solve this problem. Now I'm simply going to work on the first equation, then move on to the second equation. Let's link this equation to this one. So if you take a look carefully at the first equation, is going to be written on the form of the quadratic binomial here. So let's do it quickly here. So we get p plus number 1 as a quaternary square, which is going to give us p squared plus 2p plus number 1, but we have number 3 here. Let's move on this to the right side. So I get here, then take number 2 as a common factor as well. I get 2 is multiplied by y squared minus number 1. So I have factorized this one on the form of the quaternary square here. Let's check the second equation. The second equation we have, let's take number 3 as a common factor as well here. P plus number 1 equals 2 times x squared. So my goal, I'm going to take this one is going to look like the same. Okay, since we have p plus number 1 appears in two equations here, I'm going to make both of them are the same. Okay, so what to do, I'm going to square this one and multiply the first one by 9. So let's do that. This one becomes 9 p plus number 1 quaternary square equals 18 y squared minus number 1. For the second one, I'm going to square both sides. I get 9 here. Also 9 is multiplied by p plus number 1 quaternary square, which equals 4 is multiplied by x to the 4th, like this. Now we have a quadratic here. Okay, let's do this equation equals to this equation. So I get 18 y squared minus number 1 equals 4x to the 4th. I'm going to cancel number 2 from both sides. I get here number 2 here. Here becomes 9. Okay, so what to do, I'm going to move over this 2x to the 4th to the left, and so let's take this 9y squared as a quaternary square. I get 3y or is raised to the number 2 as a power. Let's move over this 2x to the 4th to the left. I get minus 2x to the 4th, which equals 9. Okay, so if you take a look carefully here, this one is going to be almost written on the form of the Peel's equation. Okay, so what to do here, I'm going to transfer this one into the Peel's equation. So let's square this one. Let's put this one on the form to here, then square this one like this, then take this one as a substitution like z, and replace this one with w. Okay, let's put it here on the side. I get z equals 3y and w equals x squared, like this. Okay, now my new equation becomes z squared minus number 2 w squared, which equals 9. Now the equation is written on the form of the Peel's equation. Okay, this is Peel's equation. Okay, which is written on the form of x squared minus d, so which is written on the form of x squared minus d y squared equals n. Okay, that's what I found, almost the same thing here. Okay, I'm simply going to find the solution for this equation by working on both equations that we have shown before. So we get this equation. Let's set another equation which is in the form of z squared minus 2w squared, which equals number 1. Okay, so I'm going to find the obvious solution for this one as well as this one. Okay, it's more simple here. Let's call this one as equation number 1. Let's call this one as equation number 2. Okay, let's find the solution for both of them. For this one, let's call it alpha as a solution, which is going to be represent z0 and w0, like this. Okay, so it's more simple here. If I'm going to replace 9 here, I get 81. If I'm going to replace 6 here, I get 36. 36 is multiplied by 2, which is 72. 81 minus 72 is going to give us 9, which means we get 9 and 6 is verifying this equation as a first obvious solution. What about this one? So let's put this one number 1. Let's work on the equation number 2. So we get beta as a solution, which equals z prime 0 and w prime 0. So also, if I'm going to plug number 3 here, I get 9. If I'm going to plug number 2 here, I get 4 square, which 4 is multiplied by 2, which is 8. I get 9 minus 8 is going to give us number 1, which is correct. So this one is verifying this equation. Okay, so I get the solution 3 and number 2. Okay, so this is for the equation number 2. So as we have discussed before, we know this one is going to be written on the form of the recursion, because it's written on the form of the Peel's equation that we have shown before. Okay, so what's the solution for this one? The general solution. The general solution is going to be, let's put it beta n. I'm changing the, let's put this one as a beta 0. Okay, so it's going to be plus or minus this solution 3 plus 2 square root of 2, because this one is representing d. Okay, so always make sure a square root d is not integer. Be careful here. We get the integer here, so when we take the square off, then it becomes integer like this. Now this one is raised to the 2n plus number 1. Okay, I'm going to consider, if I'm going to take the first solution as 0 solution here, so it's going to give us a b solution if I'm going to replace n with 0 here. Okay, so we're taking n as an exponent in general. So if I'm going to consider this one, you can put this one on the form of this form as well. So this one, what is going to happen here? As you're replacing n with a new value, we get a new solution. This is the Peel's equation, but this one is valid for the second one. Okay, so as we discussed before, but we need the solution for this one. Okay, what we have shown before, we have shown the solution of this one, which is the obvious solution. It will be multiplied by the obvious solution of this one to get a new solution. Okay, so I'm going to replace n with 0. We get is going to give us this solution. Okay, because replacing n with 0, I get this one exactly. Then taking this solution, multiply it by this solution. So this solution is going to be written on the same form that I have here, which is alpha is going to give us 9 plus 6 square root of 2. Okay, then take beta prime, which equals this one 3 plus 2 square root of 2. Let's put it as a prime 1. Okay, so we get 9 here plus 6 square root of 2. Okay, I think it's more clear here. If I'm going to expand this one out, I get 3 times this one, which is 27. 27 is multiplied by these things, is going to give us 51. 51 plus, so we get here 9 is multiplied by these things, which is 18. Then this one is multiplied by this one is also is 18. 18 plus 18, which is 36. So I get here 36 square root of 2. Okay, what we have determined a new solutions for this equation. Is z, which we have replaced here. So we get z1, which is going to give us 51, and we get w1, which is 36. okay, here, because we had a substitution here. So which means I get 3y equals z, which is 51. We know 51 divided by 3 is going to give us 17. For the w, we get x squared, which is going to be replaced with 36. X squared implies x is going to give us 6. Remember, we are dealing with a non-negative integers here. So we get a solution for this one. We get x equals 6 and y equals 17. Now we are simply going to plug in either equation to find the prime p, okay? P, which equals 2x squared minus 3, as I'm taking this number 3 to the right side. So replace the x with 6, you get his 36. 36 is multiplied by 2, which is 72. 72 minus 3, it's clearly is 69. So we get p by dividing 69 by 3 is giving us 23. Now we found one prime as the smallest prime for this equation, okay? It's more simple. The same thing if you replace y with 17 here, you will find the same value, p equals 23. So previously we were working on this equation and came up with these nice results. We found the smallest value was p equals 23, corresponding to x equals 6 and y equals 17, okay? So now, in order to show there are no more solutions for this equation, we are going to come up with a nice proof. So the proof we are going to argue we have no solutions for this equation except the solution that we found p equals 23, okay, as the smallest prime. So now let's go ahead to see what's this. Now we are going to build a nice assumption. By using that assumption, we are going to show we have no solutions, okay? So the assumption that I will have, we are going to build this proof. So by the way of contradiction, suppose we have p as a prime is going to be written 23 plus additional value. The value that are going to be added on it, it must be even to keep the add, okay, as a prime. So this one is going to be written on this form, 2c. But be careful here. Here exists c as a natural number, satisfy this assumption, because we have a specific value for c is going to satisfy this one as a prime. It's not going to valid for all the values of c. If you take in c equals 1, it's not going to give us a prime. But if you take c equals 4, it's going to give us 29 is a prime. So as we have built these assumptions, which means there is a specific values for c which can give us a prime. In particular, is going to give us a solution. There is a special value for c is going to give us a solution, okay? Also, if I'm going to use y, we have a smallest value that we have found previously, it was 17. I'm going to add on it another value, which must be even as well, to d. Always put it exists d as a natural number, like this. So what I'm going to do now, I'm going to use these both assumptions as a true assumptions in order to build our proof, okay? We are going to use the first equation, okay? Then simply taking these values that I have here as assumption and put them into the first equation. So without doing a lot of calculation, I'm going to transfer this one into quinary square as I have previously done. So this one, it was p plus number 1 quinary square, which equals 2y square minus 2, okay? So what to do now, I'm going to take this value of p and insert it back into here. So I get here 23 plus number 1, which is 24, plus 2c, all is raised to number 2 as a power. This one is going to give us 2 factor. So y, you will have 17 here, plus 2d, quinary square minus number 2. So since I get number 2 here as a common multiplier, I'm going to take one of the two out of these things becomes 4, okay? So I get 4 here, because we have square here. I get 12 here, plus number c, quinary square, which equals 2 factor 17 plus 2d quinary square minus number 2. So I'm simply going to cancel out number 2 from both sides. So this one becomes 2. This one becomes 1. This one becomes 1. Okay? Then what to do? I'm going to move over this minus 1 to the left and move over this term to the right. I will have a new equation. I get 17 plus 2d quinary square minus twice this equation 12 plus c quinary square equals number 1. So now I have ended with this nice equation. So if you take a look again, this is going to be written on the form of the Peel's equation again. Okay, so let's set 17 plus 2d is going to be replaced as z prime. This one is going to be written 12 plus c as a w prime. Okay, so the equation becomes z prime square minus twice w prime square, which equals 1. Exactly, this is a Peel's equation. Okay, now we are going to extract the obvious solutions from this one. So what's the obvious solution? It's more simple here. Is going to be z prime 0, which is going to give us number 3, and w10 is going to give us number 2, because we get 3 square, which is 9. We get here 2 square, which is 4. 4 is multiplied by 2, which is 8. 9 minus 8 is going to give us number 1, which is satisfy this equation. Okay, so what to do? I'm simply going to replace this value that I have here and put it here to find d and c. Okay, I know this equation will have infinity many solutions for this one, but we are not going through all the solutions. I'm going to choose just obvious solution is enough to extract the contradiction. Okay, so I get here 17 plus 2d, which is going to be replaced as a number 3 here. The second equation, I will have 12 plus c is going to be replaced with number 2. Okay, now let's solve this equation. So taking this 3 to the left is going to give us d. 17 minus 3, which is 14. 14 over 2, which is 7. Okay, for c, it's more simple. C is going to give us minus 12. Okay, but be careful here. We have chosen x and y must be a non-negative integers. Here is the first contradiction because we get a negative number. Okay, now we have convinced ourselves we cannot find any solution for this equation except this solution that I have found as a p prime, as a smallest prime only, which is valid for this equation. Okay, thank you for watching. We see you next video. Bye.